my name is Furkan. Today I'm going to talk about set. So when I say the word set, you might get a picture of union, which means everything, intersection, which means the member, that the set that has the same member, and complement, which means opposite. So when you're doing worksheet about set, you might end up getting that this set is equal to this set, that is equal to that. So these 7 laws here will prove or will tell you which set is equal to which set. Okay, first I'll start with idempotent laws. Very easy, when A union with A is equal to A. And also, when A intersect with A is equal to A. Next one, associative laws. Associative laws only tell you that when A union with A, when A union with B, and union with C is equal to A union with B, union with C. And the same thing as intersection. Next one, commutative laws. Commutative laws is just tell you that it can be switched in place. When A union B, it also means B union with A. Same thing as intersect. Distributive laws. Distributive law is quite tricky. How? Let's see. When A union with B intersect with C, this will get A union with B and intersect with A union with C. How I know? What I do for my trick is that I'll circle this. I'll look at this symbol first, and then what I do is that I'll write this symbol here. This one is intersection, and then I'll pair this into this and this. First one, A union B. Second one, A union C. And as you can see, it's equal. And the same thing as intersection, alright? Okay, next is that identity laws. Identity law is very easy. When A intersect with empty set, it will get empty set. If A union with empty set, we'll get A. When A union with universe, we'll get universe. But if A intersect with universe, we'll get A. Okay. And De Morgan's law. What De Morgan's law means is that this one is hard because it will be using about the complement. Okay, when I say complement, when I say A complement, it means that I want anything except A. When I say B complement, I want anything except B. So, when set A intersect with B and complement, what this means is that it's equal to A prime union with B prime. And the same thing here is that when A union with B and prime, we'll get A prime intersect with B prime. Alright? And my last law here is that complements law. Complements laws has 6 of them. So my first one is that when A union with A prime, when A union with A prime, we'll get the universe. Second is that when A intersect with A prime, we'll get empty set. And when A complement and complement, this one, A complement and complement will get A. Remember this. And when when universe complement, this means empty set. But when empty set complement, we'll get universe. And this one, the last one, is the hardest one to remember. It would be really good if you can remember it. Is that when A minus B, it will be equal to A intersect with B prime. How do I know this? I can prove with the Venn Eulers. So I got my universe here. And then I got my set A and my set B. Alright, when A minus B, it means this part, right? And when A intersect with B prime, what this means is that I want a part that is not B, but it's in A. So it's the same part here. What this means is that it proves that this statement is true. And this statement we'll be using in to prove our question here. So as we have learned these 7 laws, you might ask the question, how am I going to use these things in my real life? Okay, you'll be using it to prove the statement if it's right or it's wrong. Let's see the statement. Let's see the statement. When A intersect with B minus C is equal to A minus C intersect with B minus C, right? Okay, let's see. Remember the laws that I said? A minus B equal to A intersect with B prime. I see this as my A, so I copy down. And then I turn that minus sign to B intersect and that C to be C prime. And what I can see from here is that I can use another laws, the law of distributive laws. So distributive laws, what it will do here is that it will be A intersect C prime intersect with B intersect C prime. And again, if you look at here, you will see that you can reverse from here to that one. So I'm trying to get it to close as what my statement gave. So let's see. A intersect with C prime will get A minus C. And here's the same thing. And B intersect with C prime will get B minus C. Okay, what I see here is that these are true.